files. It's really trippy.
Yes. Okay. Oh, because we're mirroring and mirroring and mirroring.
Yes, exactly.
All right. Let me put this down here.
Excuse me.
What's the repo name?
My repo? Don't do it.
Don't do it.
Don't do it, man.
Don't clone it yet.
Don't clone it.
Don't do it. Okay. You just need Jupyter, right? And then Matplotlib. I can walk through like the boilerplate yak shading stuff.
Shit.
Yeah. Are we ready to go? Or is there somebody outside? No? I said 34 exactly, and now I'm regretting that.
You can use the 2.7 version.
Sorry, what?
Are you going to use the 2.7 version on this?
Oh yeah, let's go download the Python 2.7 version. No.
A lot of Google, as far as I can tell, still runs in 2.7. It's kind of funny.
Yeah. Instagram switched over somehow, so I feel like they would have a crazy code base, but probably not as bad as Google.
Yeah.
Didn't Guido work for Google for the longest time?
Yeah.
Yeah. And now he's at
Well, it's
Dropbox,
fun.
and Dropbox is still on too, so.
I thought they switched over in like 2 weeks or something like that after he started. I mean, that was relatively
To
recent.
3? Oh.
Yeah. I heard it was like, yeah, Guido started there. And then they were on 3.
Oh.
It's awesome.
He just went through the code base.
Yeah, he probably has like a script. It's a script that he's like,
No, he probably just said, we're putting 10 devs on it, and they were like, oh. It's like, done.
all right. Well, it is 7:34. Let's get started with this. So, this is going to be 2 kinds of talks in one. How about that? So, beginner Python talk is something I've been trying to do at the start of every one of our meetups now, as of 2019. When I first started this, I gave a whole spiel in January, and none of it got recorded. And now I finally got it recording. So, I'm going to give the spiel again with some adjustments. So, once again, how do you teach somebody how to code in Python in 2019? So that's kind of the gist of this, is that you don't want to give them a terminal, really. You don't. I have to use one right now because I'm on Linux, but basically what you're going to want to do is you're going to point them to Anaconda now. Whether or not you think you need any data science tools or anything like that, Anaconda still is a nice packaging distribution, and you never want to use the Python that comes installed in your system. Yes?
How many people have taught somebody else Python? In this group. Okay.
Do I get to respond?
Like basic?
Yeah, like basic Python.
Even if they printed Hello World,
Yeah.
we'll count.
Yeah. So I would love to also get your input. I think Ferris has a really good take on this of like, here's how you would teach somebody Python, but also if you've taught somebody, maybe some useful tips on that too.
Right. And we'll only take about 20 to 30 minutes on this. It won't be too in-depth. So with the new distribution of Anaconda, so we're on 29.3, so that's fine. And I have that already downloaded. In Linux, you're going to want to run a shell script, and then it'll point you to all the stuff to go through the installation process and whatever, and I don't want to go through this right now, so I'm going to say no, I don't accept the license. In other distributions, it's a lot easier to install. So you'll select the version you want. So what version should we select? Right? 3. Don't teach people 2 anymore. Just stop. That knowledge is, yeah. By the way, ethics here. There is a certain company I need to look up real quick that I don't think I want to name and shame until I have confirmation, because I've heard this secondhand. This company charged extra to teach Python 3 in 2018. They taught their students Python 2 and then said, but the next course is Python 3. So don't do that either, please. If your company is doing something like that, just tell them that's not right. Come on now. Anyway, so Windows, Mac, we're on Linux, so we hit this download button. It'll go here. We download it, we install it. It's going to ask you, do you want to install Visual Studio Code? I used to say no to that question a lot, right? I'm a Vim guy, like I'm a Linux guy. You take me away from my Vim or Emacs and I don't know what you're talking about. You can't have that attitude when you're teaching somebody how to code anymore, because code is just another tool. It's not about computers anymore. It's about getting computers to do stuff for us. If you're training somebody to be a core like Linux or Python developer, or somebody to actually hack on the programming language itself, yeah, sure, maybe they should learn a bit more about the tools and get a little bit more in depth. If somebody just wants to set up, you know, a soil moisture detector on a Raspberry Pi using Python, they don't need to learn all this stuff.
I would actually say if somebody's like trying to have a religious argument about IDEs and trying to teach you, you should just run the other way.
Yeah.
Stupid.
I'm always been of the opinion that you shouldn't use an IDE to learn Python, which is why I find Visual Studio Code to be that happy medium between a straight up like IDE and just a plain old text editor with no syntax highlighting.
What is an IDE?
Oh, what is an IDE? An IDE is an integrated development environment. But here's the thing, Dylan. I shouldn't have even said IDE at all. I'm trying to teach beginning people how to use, like, how to code. You shouldn't say IDE. They don't need to know about that. All they need to know is code is just what? Words. Okay? Has anybody, this is a very esoteric reference, and I'm hoping it's not in this crowd. Has anybody heard of Why the Lucky Stiff? Anybody? Okay, so Why the Lucky Stiff, I'm going to go in a segue here, because he's awesome. Why the Lucky Stiff was a Rubyist, and no scathing remarks please, back in 2007, he wrote Why's Poignant Guide to Ruby, which was an emotional graphic novel about 2 cartoon foxes learning how to code in Ruby. It also was released with a 12-track soundtrack that teaches you the primitives and all the other types in Ruby. Ruby doesn't have primitives, so it teaches you about all objects. And my favorite chorus from that was, get it through your head that programs are just words. So, Y was doxxed, unfortunately. He tried to stay super anonymous, and then he was doxxed in 2010, I believe. And so he deleted everything he ever made on the internet, and so there's just mirrors of it. But Why the Lucky Stiff is still out there on the internet, 10 years. Ugh, somebody took this and turned it into a blog. That makes me so sad. But yes, he had his own Twitter. Let's see. There's a Y mirror. Stiff.
For all of you using DuckDuckGo, this is why I don't use DuckDuckGo. I feel like you cannot find what it is you're actually looking for.
Or I could do that. Right? Could bang G and then just go here. If you use DuckDuckGo to Google something, though, what's the point? So this is the mirror. He also wrote this really awesome library in Ruby called Shoes. And it was a whole, like, it was like before Atom existed. It was actually like a clean, like, graphical user interface input. Anyway, I really like this guy. He was a really big inspiration for why we do a lot of this stuff as a group. But yeah, let's see. I wonder if I can find the actual... I guess I can't right now. I want to show everybody the cartoon foxes, but I can't right now. But anyway, I'll show that later. But anyway, you download Python 3, you're good to go. And then Visual Studio Code. I love that you just run code. And I'm going to close this workspace. And let's go to a different spot altogether, shall we? So, that may or may not be proprietary code. Nobody look, okay?
You still call it a temp board?
Yep.
I mean,
Century you live in. Sorry.
Close workspace. Let's just do it. So you'll get Visual Studio Code, and when you make a new Python file, what's really nice about it is it's going to load the extension for you by default. If you have Anaconda, it will already source all of the little exports and the library references and all that stuff for you, so you don't have to bother with it. If you really need to change it, you can go to the bottom left right here, and you can say, hey, I want to use this specific version of Python for this one thing. And of course, I have a ton because I'm working on Python stuff all the time. But in this case, we'll stick to the default. The other thing I really like about Visual Studio Code is it has a built-in terminal, which is just handy. Also note, when you open the built-in terminal, it already activates your code environment in the terminal. So that being said, we can show them print statements, hello, and you tell them, hey, just type in Python hello.py, and there you go. And there is something magical about that first hello world, isn't there? Right. But we can do better than that. I wonder if this works. Yes, okay, so one thing I do like about Linux. So we're SLCPython, so let's give them a cowboy hat there. So what does this? I don't know. Everything. Are you kidding? Embrace the cowboy hat emoji. I know, I kind of wish we were Texas Python, but we're Utah Python.
It's 47.
Sorry?
I think it's days of 47.
Yeah. So, anybody know this trick in Python 3 yet? No? That you can set emojis as variable names?
yeah.
Try it.
Do you think this will work, or is it going to break everything?
How is it going to work?
Nope.
What?
I know, right? Makes me
Oh, they only support a subset.
Do they? I think I might have mispasted, actually.
Really?
I guess
Yeah, I
not.
think they only support a subset.
That makes me sad. I wonder if this is part of the...
I think they support pi. You can actually name pi as the Greek character pi. They added this because guess what? Not everybody in the world speaks English
Really?
and wants to code in English. So, you can look up a Python 3 Chinese version.
Oh,
See,
like
you
actually
can
type
see
in
code in
Chinese?
other people's languages,
Mhm.
like French Python 3.
Does it,
There.
things like print, right? Statements.
The keywords are still in English,
They're still in, okay.
but
just
all
wanna
your
make
variable
sure.
names, function names,
Yeah. Can actually be-
doc strings can be in Unicode
Nice.
without having to do anything.
I imagine, you can, ever since functions are just objects, you could just make, a Chinese symbol equal print, like the function, and then do that, I suppose. Which
Well,
I'm sure that
no,
happens.
but it's part of how the Python interpreter compiles it into code.
Yeah.
Changed with 2 to 3.
Right.
Oh,
Well,
yeah.
you can make the variable the function, and then
Oh, okay.
you can use smiley face equals print.
So a couple other things. If you're teaching somebody how to code,
Oh god, that's
Actually, you're
horrible.
totally right.
typing in Python hello.py over and over, that might not be the best. Of course, the main thing that we all love about Python is the REPL, right? No, it's community. That's the main thing everybody likes. But the REPL's pretty cool too. So, who knows what a REPL is, or doesn't know what a REPL is? REPL What's it stand for? I forget.
Read regular expression.
Is it? No? REPL? Read, evaluate, print something? What's L? Loop. Okay, so, which means you can, line by line, you can type in Python commands. Foo for y in range. 10, print x. So you can do any kind of Python expression that you want to in the REPL. But even this may not be as accessible as Jupyter. Are you ready, Dylan?
So wait, I don't still understand. What is REPL?
Read, evaluate, print loop. So do you know how
It's just an acronym.
yeah, it means, you know how I typed in Python here and I started able to hack? I'm able to execute one line by line of each Python code.
Your terminal is actually a REPL.
Gotcha.
Like it's, as you type in bash commands, there's a program listening, it's in a loop for evaluated statements.
For people coming from a C#, C++, or Java background, or any of these compiled languages, you're used to, this make step where you have to make, or you have to compile it using the compiler that you're using. Python comes with its own compiler and leaves these lovely little PYC files everywhere. Well, I guess not here, but and it'll byte compile them down, and then those are faster to execute next time it has to evaluate and interpret that. So it's an interpreted language. But even then, this is a little bit more powerful. Oh, did not like that, did it? I wonder. There we go. It's because I ran it in this one. I'm trying to remember why that would break it. Whatever. So, another thing we got over here. So this is a Jupyter Notebook. So all you have to do is type in Jupyter Notebook. If you install the Anaconda distribution, this is now on your command line. I believe on the Mac and the Windows, it becomes a shortcut. Am I wrong about that?
You can.
Yeah. You don't have to go through the terminal to get there, right?
For what?
For Jupyter Notebooks. So you saw how I opened it with Jupyter Notebook. I'm trying to remember.
I think there is another way, but
Yeah.
I just use Jupyter Notebook.
Yeah, most people will just use the command line, but I did recall that this was like one of the cool things about the new Anaconda installation.
I don't use Anaconda.
Yeah. So,
Like the last guy I know who doesn't use Anaconda.
yeah. And then I think, Dylan, or you can use Jupyter Lab, or no?
Yeah, I use Jupyter.
I just find
I like
bugs.
it a
I
lot.
know it's weird.
Yeah, so what's nice about this is that you can actually start up a Python 3, they call these notebooks. So here's our notebook. I'm going to name it Demo. And just like we had a REPL before, we have the same thing where we can, let me make this bigger. We can print howdy. And then we use Shift Enter for executing that. And we can actually go back and edit it as we want, execute it again. Notice that because it executed twice, we have a 2 there now. And
One cool thing, is anyone who has a Google Gmail account? Like, who has a Hotmail account, just so easy. So in Google Drive, they have what's called Collaboratory. So it's hosted Jupyter Notebooks, and it comes fresh with most of the data science tools you need, like Pandas or TensorFlow. And I think you can even run it, they have GPUs you can run on too. So they definitely give you a GPU to run your machine learning code on. Wow, that's pretty cool, and it's free.
oh look, it's even easier.
Yeah, it is. It's not as cool looking, but it's...
Well,
That's
what's
better.
nice about this, I guess, is you can do it collaborated, right?
Exactly, yeah. And then
And
if
then-
you don't have to worry about like
Installing everything
running
locally.
Jupyter Notebook, or if you...
My issue with these is always what happens when you need to install something.
You
Okay.
can pip install.
You can pip install it? Okay.
Code auto-completion requires a connection at runtime.
The problem is you have to be connected to the internet, so
Connecting to the internet.
if you're on a
Initializing.
cruise ship or something, you're...
Ah, import pandas. This is usually how you do it, right?
Yeah.
There you go. There's pandas is already.
No, I mean, if the package is not available.
Oh.
Right?
What,
You need to pip install.
if you preface it with a,
Yeah.
if you
No,
preface it with
I-
a bang,
yeah.
pip
Yeah.
install.
That was my question.
You
It
can-
sounds like you can.
Pip install.
Like Django or something. Oh, how do that?
What's Utah?
What's that package?
What?
Yeah, what is that package? Is this a hidden little package that I've
That
had
somebody
sitting in
wrote?
the background as an Easter egg for the first person who contributes to our website? No. Well, enough about Utah for people to look up as an exercise to the reader. That's kind of cool though. That's a good tip. Collab.research.com. I'm gonna put this in our
Well,
ether.
yeah, it's nice if you wanted to test out like machine learning code, especially because doing it on your laptop sucks for a lot
Yeah.
of reasons.
Yeah, but then you can't do machine learning on a plane, you know,
Well,
unless the plane has internet.
try me.
Yeah, so that's pretty cool. You ready to go there?
Yeah.
You want to hop over here and tell me what's your first imports right here, and I'll start importing them with everybody.
Should we take another little break?
Yeah, we'll take another little break.
Are you writing like Anaconda updates or something?
Are you trying to install?
I don't need to install them.
Okay.
I just want to know what imports you need.
Oh, Matplotlib.
Yeah.
Yeah.
Where is Matplotlib?
Just import Matplotlib. Import, and then import file or pandas. Yep. And import NumPy. Why not?
Arbitrary execution. But it's a nice little thing.
Definitely pronounced that numpy for like a good 2 years.
Yeah.
I still pronounce it numpy.
I usually actually, I've heard it both ways.
Actually, I think it made when it first made up here, someone said numpy, I'm like, oh.
Yeah.
That makes more sense.
Cool. Are there any more questions on
Beginning?
Python stuff?
Anybody completely hate the approach and would never utilize it at all? No? Okay.
Cool.
That's
I like
a
the
bit of a
focus on
load.
emojis.
It was fun to mess with the
We're gonna
emojis.
cover like data types every day.
No. No. I'm
Figure.
maybe I've been teaching too many like 12-year-olds, but they seem to get obsessed with that.
The scenario I always find myself in is people know this stuff,
Right.
right? And now I need to teach them how to code.
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 Mm.
Right?
So what
Python 201.
Right.
Right.
I have an approach to that. So what I usually go through with people is you get it started, right?
Yeah.
So like, okay, I got it installed. Then I go through variable types, so just talking about variables, what a type is, how you define it, why they're different. If your language requires you to specify it versus Python where it's dynamic, then you don't necessarily have to spend time on the specifications.
When you're talking to scientists, right, a lot of the time they get that stuff, right? They've done a lot of scripting,
Variables.
right? They
Control
understand-
structures.
They understand even control structures, but you want
For
to go from
loops.
there to something like object-oriented or putting together a package.
Yeah.
And
So
putting
I
it
just
in
I work
practice.
through those steps. So variables, control structures, data structure, functions, then data structures, or
Right.
maybe flip them depending on where somebody's at. And then once you kind of get to functions, then the jump to object oriented is like, okay, now you're collecting functions that relate to a common thing. And so then I make sure that the person has those pieces
Sure.
going through.
my personal approach is to have, especially with kids, start working on a project, whether it's like something like, hey, make your own blog post, or with the hardware we made, meme generators and stuff with that. You're teaching people how to like import stuff like, hey, I need to import random if I want to randomly display stuff. I need to work with I/O. How does that work in Python? What is I/O? And once you're solving like an integrated problem, then those kinds of questions might appear organically, but it also depends on the kind of people you're teaching, right? If you're teaching a workshop of adults versus, I used to teach 85-year-olds how to use computers in Vancouver, like that's a completely different audience, so,
Sure.
yep.
Who's your audience? for this?
Data scientists.
Okay,
Data
so I would go with
scientists. So you're
85.
teaching data scientists to code, or like
Yeah.
to
Well,
program?
how to actually code?
Yeah.
They know how to code.
Yeah.
What I've found in teaching data scientists, and especially because I tend to recruit from social scientists a lot, and recovering already includes the whole gamut, so kind of pushing finishes. And there's the technical skills, but you need to teach them how to program. As soon as you can because then you can start, they're used to thinking, okay, hypothesis, test it. And just teach them test-driven development is the first thing, and then they can keep building on that. Like, oh, this is worked out. Oh, let's run a test and see if it works. And it's been really, really helpful.
On that note, too, is maybe give them steps of code. I know Rico used to do this for his interview. He would give you like a broken Django project, and you would fix it, and that would be your project. But probably something similar with even TDD, where you give them like a method that's intentionally broken, and then you have to fix it.
Yeah.
And by doing that, you're gonna learn a lot.
On their first projects, I'll set them up in a pipeline that has code running on already.
Cool.
Another one that I have is like abstraction. Like, how do you abstract into into modules, right? And making that an emphasis, because a lot of like you go just serially script it all,
Copy.
Yeah.
paste, yeah, right.
Yeah.
So I would start with like, how would you import this from a library
Yeah.
and
Yeah.
make sure that you're trying like move them towards dry, because it is often.
Yeah, and I think with data
Standards,
science,
too,
it's
right?
like, has
if
to
I
be
think if you don't come, if you're coming from
Yeah.
a kind of a background with no coding standards, also enforcing coding standards really helps, and thankfully Python has it package, but it also seems to be because you may know how to code, but you also probably write really shitty code and that nobody can read, and, so
Much less communicating.
bingo, and that's like usually part of the problem. Like we've been hurting code bases, and it's like I don't know what the fault stuff is.
Yeah, this is make me feel good.
Yeah.
Kind of where I was going.
Okay, cool.
And
Yeah.
I know people don't like IDE, but Python is so nice for R2 users.
Well, here's the thing. A lot of scientists, especially, they'll get stuck in the in-house syndrome thing, where they think they have to reinvent the wheel because their way is how they think about it, and that's how the world should think about it. And just gently remind them that they're thought leaders in other things, and this isn't one of them. So, like, if you're writing a JSON parser, you've gone too far.
Yeah, not somebody who wrote their own database once. I thought that was really weird.
Yeah.
Like for production.
I guess. I don't know. He was like really happy about it. I was like, but it sounds like
Do you
a
need
lot
a
of databases that are on the market right now. Do you make your own toothpaste?
Do you need like an
can.
adapter?
You can.
Tell you what?
Do you need an adapter, or does it have it?
Good.
No, this one has it.
Okay.
I still haven't been upgraded.
Good. Do you want to be?
Oh wow, that's funny.
I want the more RAM.
Yeah.
I'm like crushing my RAM right now.
Well, I think I can fix that aspect.
Oh, let's do it. Like, everybody stand up. Let's take a collective breath in together. All right, 5 minutes. You can take a bathroom break. Talk to the people around you. Do that. Thanks.
Can you change your resolution?
Yes.
Oh, Japan just landed an spacecraft on an asteroid just now.
You learned that on your phone, on your watch.
Yes.
That
The future, man. Get with it, Jacob.
Is that good?
Japan just landed an autonomous drone on an asteroid. Japan hasn't.
Do you know what's going on with this space?
With the display, you
Like the
have
resolution?
Yeah, there is a trick to this. I'm trying to remember it. Click optimize for it. No, it's not getting that. No, try.
Oh, do I need?
I have to press like a button on this one. It's really dumb.
Oh.
If that doesn't work, I have one more trick up my sleeve.
So we're
I don't know what's up with this.
What kind of paper is it?
It is a. Hey Maria, what's the projector name? What's the brand? There's a trick to this. I always forget it.
The idea is to take but yeah, you take yeah. The goal is our goal is to bring it in there.
It's sending the wrong one down the line, I think.
I mean, because I should be able to model test out.
I don't think that'll help. You can try.
You know, it also
I have the one that'll. No, then I won't be able to.
Present.
Yeah, what did you unplug? No. Wrong order. Wrong order.
No. Just see.
Oh, if it's.
Yeah, I'm pretty sure that it's not necessarily projected. There's something about the HDMI and how we're transmitting it.
We got a place to make it symmetrical.
pretty similar. We actually,
Those are like programs where you like typically run
You're on the right channel.
yeah, we have we definitely
I got used.
We'll go back in.
I haven't bought a new.
Because that is where we're Okay.
Go to displays again.
I paid $75 for that.
Yeah, try and
Yeah, no, I got it maybe about a year ago. So, it's expensive.
I have a newer one.
There we go. It's done that you have to tell it.
Ultra folio 1040. Oh yeah.
It still has used the organizer, so it was like, Dylan's looking forward to seeing you at the meetup
I
today.
think it's like a 2015 model.
Yeah, I saw that. I was like, oh, I'm the organizer.
Is this your little presenter?
Yeah.
Okay, so the swing dance is done like this, okay? First foot forward and then on the downbeat.
I'm going to
So it's sort of like,
While we're waiting for Dylan to come back, has anybody not gotten a name tag with a number on it? Anybody? So they should be available on the desk back there. Somebody can help you.
I know, right?
instead of like,
And if anybody was waiting to use a credit card for their optional $5 donation, we're ready to go over here.
Do we do Venmo? Yeah, but yeah.
Here, I'll just open it. It's probably easier, right?
Yeah.
It's easier for me to
I've seen where it works.
Oh, like history on AI. I think this is my go-to. I have there's a little cheat sheet someone made. It's really good. It's a small screen. Like, is it H?
Hand it over to Ferris.
No, yeah, maybe that is how. Yeah, I seldom use it. Oh, maybe it'll be helpful.
There it goes. Do you know how to navigate though? Because I know you can. $5. You see these, but I don't know. Dylan.
Yes.
Matplotlib and Seabourn.
These are the
Yes.
these are like the files themselves.
Where's the Altair or some other stupid
Basically.
You know, I've tried them all, and I get about partway into it, and I'm like, this is stupid.
Well, I always just think about this. I use applications. Whatever time I get it,
but I know how to do this on
Did you ever try ggplot? You're using ggplot.
I know it's the same though.
I mean, I've used the GG+ style.
Have you ever used the BI tool?
Interesting.
Or had to support a BI tool?
Very recently,
Like Tableau or
I started using Power BI.
Yeah, this is like the of the eye.
essentially what a lot of like the way those tools work is they have a base table and then you specify which columns and you do operations as part of this transformation and visualization, right? And that's all that happens. ggplot works the same. You always have a base table and your visualization, if you want two things in it, has to be in the same table. And that bothers the piss out of me because basically all the time I'm like, oh, trade this data frame, this data frame, this data frame, put them in the same plot. I don't want to have to create one data frame every time I make a plot.
It doesn't work so well when your data gets big, right?
No, I'm just like, no, just put this one on here and layer this one, layer that one, done.
It's like you end up having to do the merge and everything every time anyway, so.
Yeah. And I'm like, then the merge operation costs me.
Okay.
And I'm like, no.
I think it actually. I think it might actually be good.
All right, everyone, find your seats. Let's do some data visualization.
Data visualization. Really good for us.
We need more theme songs in Python.
We should do like Python karaoke sometime. I don't know what that would be. It'd be kind of dumb, probably. Yeah, me neither. Yeah. Well, the just
Party pooper.
I think it'd be awesome, actually. You brought up this awesome idea and just smacked it down already.
All right, so my talk today is on data visualization. How many people make a plot daily as part of their job? Cool. We're gonna have a good discussion here. How many people would not know heads or tails of how to make a plot in Python? Got a few people. Okay, cool. And I think I have some content for you. So we're in between, meeting in the middle. So my name is Dylan Gregerson. I have these various interests. I have this cat who's very dear to me. And I eat vegan food, which is delicious and great, and you should also try it. I work at WeWork along with Ferris and several others here. You can find me at LinkedIn. Okay, so I like to have my talks not just be about nuts and bolts. Here's a function that you use in Matplotlib, but to put it into context of why we're talking about what we're doing and how it fits into the why of what we're doing. I'm also going to preface this with this is a revamp of a talk that I gave over 4 years ago for the Python meetup. Yeah.
It's a repost. It's our first repost.
It's like the first redo talk that we've ever done.
Yeah.
Yeah.
It'll be fun to see what's changed. Sorry for the rerun, but has anybody been to this talk the first time?
Joe.
Yes. So Joe, you can leave.
I'm really old and forgetful.
Do you remember that? I think it might have been my first talk at this.
No, your first talk was on Python 3.
Was that?
Yes.
Okay.
It was the Python 3 talk.
Might have been my
Still like
second
the
talk.
Your
at
second
this.
one was about visualization.
So which number is this?
I still hold the record. I don't know.
Yeah, I think Dylan is in double digits in terms of talks. But
Yeah. All right. So what we're going for is what Tuft calls graphical excellence. Tuft wrote the book on graphic visualizations. And what his concepts are is you have your data information, you have this interception of ink on a page and space, you have the person who is viewing it and their thoughts about what this means, and you have the time it takes for that person to have an idea about what this means. So all of those pieces are the critical pieces at play when we're making visualizations. And so his practical rules for graphical excellence is that you have an honest representation of the data. It's visible and clear. He really likes multiple layers of information. Having worked with people who are very data illiterate and creating it for audiences that are, sometimes your layers of information can cause confusion. So you want to prioritize clarity, possibly over layering information, though I love 10-dimensional plots. Tailored for your audience relates again to that particular thing. If your audience, people are not good at thinking in 3 dimensions, and it takes a lot longer to process that. And if your audience is not ready for it, don't do it. Do something simple. Do you want to add something to that, Joe?
The only thing, if you could go back onto that chart, that one.
Oh,
if you
we're
could
going to talk about it again
Yeah,
in
okay,
a
cool.
second.
It's a cool story.
Yeah.
And if you have animations on that chart, that'd be cool too. We'll talk about chart jump. Just joking.
Oh, yeah. All right. Speaking of that chart, do you know the whole story of this chart? Or do you just know the data around it?
I've read Tuft's book.
Yeah. I actually haven't.
Oh, you
I
have?
skipped it.
Oh, one of those people.
Yeah, one of those people.
Yeah, it was just Napoleon's tracking the progress of his march towards Russia.
Yeah.
So
Do you remember any of the information about why who made this particular chart?
I don't know who it was. It wasn't him.
No, it definitely wasn't him. But this was his this is the best plot ever in the world, because you have this is tons of data, tons of levels of information. So when you think about in plots, thinking about dimensionality, you think, oh, X and Y, oh, and you can only add Z, that's dimensionality. But actually, when you have X and Y, that's 2 dimensions. If you change the color or the size, each of those is an added dimension of information. And so in this graph, you have quite a few. So we actually have the width of this represents how many troops that he had at any given time. You actually have your spatial dimensions, they went from here to Moscow, got totally trashed, came back, and the last 10,000 people were real sad.
We're happy because we made it back.
Yeah. And you can see throughout it they actually split off and then joined back up on their way back. And you have this information about how the temperature affected them, because the story it's because they decided we're going to march to Moscow, and they didn't realize that, oh, it's a lot warmer here than it is here, and we're just not ready to deal with that. And so this graph captures lots of different layers of information, and fits into his graphical excellence. These are this is a representation of a bad graph. Who can tell me why this is bad?
Chart junk?
Chart junk. How do you define chart junk? Bad. Wait. How do you know? What on here is chart junk?
All of it?
All of it. Okay, so what on here isn't chart junk?
The box?
Yeah. Well, so you do have, like, we have time along the x-axis. That is real data. That is real information, right? We have some idea of, like, a value, though they've obviously, like, interpreted that very roughly. And we actually have some scale, and it does just so happen that the scale is even. That is important. Not all scales are even, but this one is. And so, like, those pieces are actually real data. The part that is not, that is cluttering up your interpretation of the actual information, is all of the other pieces.
I think that's great.
Are you using a presentation or something?
Well, like, what year was that made that was okay?
Yeah, I was gonna say the other thing wrong is the straight up misogyny.
Yeah.
There's a few social issues that are addressed.
I don't think that applies. Tableau should add that as a template.
All right, how about this one? How do people, I want, like, is this a good chart or is this a bad chart? Who says it's a good chart? Who says it's a bad chart?
Who's undecided?
Who's undecided?
I think it's fairly.
So what does it tell you?
Yeah.
So if you remember back, we have data underlying this, right? We have the actual information being, like, how we presented it into ink. We have you thinking about it and the time that it takes you, right? So actually, who has an interpretation of what is going on here? Who can tell me what does this data mean?
Does anybody know the Bckelt test?
Bckelt.
Bckelt. How do you say it? Bckelt.
Go ahead.
So this is the, what fraction? In a given movie, are women talking to each other not about, well, it's the Bckelt test. What fraction of movies are passing the Bckelt test over time? So 77.4, etc. And it's getting, well, it was getting better over time until 2000, and it started getting worse again.
Yep.
So.
Did it get worse?
Well,
No, because there's,
Well, what does worse mean?
yeah, that's
not clear.
Yeah, because
Possibly.
the fewer than two women part, see, there's still a bunch of red, and we don't know quantitatively if that's
I don't know what
worse.
failure means,
Yeah.
right? I don't know what pass means either. So I don't know if you're doing good or bad. Or if you're just passing or whatever.
It does look like there hasn't been, like, I would say there probably hasn't been much change. Like, assuming that there is some amount of uncertainty in our data.
But also, what does percent mean?
It'd be, so my interpretation of this.
Oh, thank you. No, I mean, but like, what happens? But if it's like 5 movies or something, right? Like, you know what I'm saying?
What is the
So-
sample base? There's more than 5 movies.
Well, they do have it over 4-year time ranges. 3 years?
5.
5? Is that 5? So that is, so the Bckelt test, if you're not familiar, is like, if you take a particular movie, are there women characters in there that talk to each other about anything other than the male characters in the movie? It seems like a really low bar, but this is what your percentage is over time. And it's real interesting when you start to think about this, because even movies that you're like, oh yeah, the Avengers had this whole scene of, like, women coming together and fighting. Did it pass the Bckelt test? Very dubiously. I would put it in the dubious pass. And if you pay attention throughout it, they're talking about your main male characters in the movie. That's totally, like, that relates to the data in this and just our interpretation. I like this visualization because it has lots of layers of information. So we have actually the dimension of each of these as a percentage. We have time, and we're specifying this, like, information about pass and fail. Any other comments on this one?
I think if you know what the test is, it makes more sense to you. So it would pass it because it's conveying information to people who know what it is. But it would fail if you're trying to convince, not convince, but demonstrate what the thing is.
Yes.
Somebody does not.
I think to your
That's
point,
fair.
tailored for your audience, right?
If this is in the context of some other article about it, it
Right.
mentions here.
So is the fail the black line and above, or is it the?
It would be the black line and above.
The problem I have with these kind of charts is that it's difficult for, especially non-technical users, to perceptually tell changes in categories that aren't the top or the bottom.
Yep. So if you didn't understand that, it's essentially like, is this bar bigger than that bar? Tell me right now. I don't know. It's hard to know, like, okay, like how much of the change is happening, especially for this dubious, whenever you have stacked bars. But that's a very particular thing about stacked versus side-by-side bars. What this does do a good job of is telling you this sort of overall percentage, and you may want, if you're tailoring it for your audience, to, in some cases, I would say get rid of your extra layer of information here and just go to pass and fail. So they've used red and blue to encode that information, and then this shading to encode this extra dimension where you're getting more fine grain. But sometimes it's useful to use redundant information. That's my computer going dead. Or going quiet. So tailoring it for your audience, but overall this is like much better than this one.
Oh, everybody's favorite.
Just skip this.
Yeah.
Just skip this slide.
This one online. Who wants to pick this one apart? How does this achieve or not achieve graphical excellence?
Like 30 of what? Green.
Of the pie.
Of the pie.
Sure.
It doesn't add up.
Tell me how that adds up to something.
So often in pie charts, you don't get a sense of the absolute value. They're apparently trying to help you, but then I don't have a sense of what the percentage is.
But I like the 3D part. That really makes it clear. So, because without that, I would be really stumped as to what it's trying to say. But.
Yeah. So 3D-ness is chart junk because it doesn't actually add information to your visualization. It's actually detracting from it. It's adding something that doesn't directly improve the visibility or clarity of it.
Now, if it was like soup sales, right, and you did like a can for each soup, then that would be the only time that would be
I
acceptable.
like that they put a drop shadow on that though. That's
Oh yeah, no, that's important.
Well, like to be explicit, right? Visually, like your proportions don't add up correctly because you see the bottom side of that, the green and the blue versus the red.
Well, Ken and I always talk about this too about pie charts. Like, it's probably the dumbest chart you can use because it's like your mind can't wrap its head around like proportions of a circle.
Well, I mean, the only time you do is pizza
Okay,
So
or cake.
to expand on that point, and actually to build on Jacob's, when you think about the ink that's representing your data here, in a pie chart, the piece of the pie that has a bigger radial piece actually has more ink. There's straight up just more green here than red, and it's not related to the percentages ever. Like, the percentage that you see on a pie chart, if your piece is bigger, is actually more area than is actually represented by the percentage. And so that is, in a nutshell, why pie charts they actually misrepresent your data from an interpretive point of view.
They also make it difficult to comprehend the difference, especially, I mean, 3 is kind of okay, maybe, but you add like 15, and it's just like, oh, there's several small slices.
And how many people have seen that in the real world where somebody has an Excel chart, Excel report with like 15 slices of a pie? Anyone seen that?
Yep.
Did it make your eyes bleed? I guess you don't still see, so.
It's even better when they're in a newspaper that doesn't have color.
Yeah.
And you start using hashes.
Yeah.
Though, and the caveat to that is that pie charts are still very easy for people to grok. And so if you have something that's 4 or 3 big, like using a pie chart can be very useful. I still put them into graphs. I still put them into reports.
One thing that's really bad is when you have a grid of these, so you're trying to compare.
A grid of pie charts?
Yeah.
Yeah.
What bureaucratic hell?
I'd say at that point, like, yeah. That should be one of my examples here.
Which local government office was that?
I've seen.
Can you see the graph on this? I love this. There was this whole time when I just like, I actually have like a ton of these examples where I was just like finding charts and looking for different examples. There's this, yeah. So this one, if you look down here, there's a bar chart on its side. 0 is somewhere between 1 and 8.
This was so close to being a good chart, though, I feel like.
It's yellow.
Yeah, and why so?
Oh, because it does actually list stuff out. If it wasn't a range, I feel like it would actually be less ink than putting a scale on it, and or
Like if you were to
Well,
put a
if you look-
separator in there.
Yeah, but okay,
It's not
so
the
1 to
scale.
8 is apparently half of 25 to 50.
right.
So I got another example for you.
Well, it's a log scale.
Here is the other version of this same thing.
That's even worse.
I didn't know caffeine was related to heat.
Oh, they are using little things.
Yeah, where your height is actually proportionally. So you're representing information by the actual visualization. Yeah. I'm not exactly sure what I wanted to say with this one. That was an old one. All right. XKCD, you have fractions image that's white, fractions that's black. Very accurate pie chart. Amount of black, and then the position in this image of where the graphs are.
So meta.
So meta. All right. So that's my, like, in the nutshell, talking about visualizations and why we're making visualizations. So I wanted to go a little bit more into detail about creating them with Python. So Matplotlib is like the de facto, everybody uses it. There are other options out there. Matplotlib, however, is great for exploring. It's good for creating static content, not necessarily dynamic, where something would be like JavaScript-y interactive, but it's good if you want to get an image of it, and you can do very complex visualizations using it. Yes. This recommendation I'm not so strong on anymore. So if you're using, you can use Matplotlib within, if you're creating some sort of interface for somebody to interact with, it's very good to treat it object-oriented. But I have switched over into just using the state, the global state, and editing it that way. Mm-hmm. I'll talk about that in a second. Modularizing your plots. So this is something that goes back to your data scientists. Don't just keep copying and pasting. If you're always naming x and y the same, make a function. And then separate your data analysis from your plotting. So these are some, this is both about Matplotlib and some of my tips. So that one in particular, if you're doing a bunch of crunching and then visualizing, separate those out, because it makes it a lot easier to have all your data together and then to make your visualizations after. All right, so Matplotlib in particular, Matplotlib is old and clunky. It has some of the worst results of being open source, and just let's add in this thing, and let's add in this thing, and somebody else writes it over here, and then they add it in. So there's not a lot of standardization. There's a lot of functions in Matplotlib that are just like hexbin is an example. You give it x and y, it creates a hexed visualization for you. But at no point does it give you the object before it creates the visualization. It's creating the visualization as it's doing its binning, and that really sucks sometimes. And then its defaults it has some, like, their defaults for how they make visualizations are sometimes not very good.
And the views are
Everybody loves the jet color.
Everyone loves the jet. However, on the flip side, it has a large community of users, and basically anything that you'd want to visualize, somebody has written something that can help you through that process. It is really comprehensive.
Not only has somebody written it, but it's probably on Stack Overflow.
Yes. Yep.
Copy the code.
So much Stack Overflow code, or like examples, so many of that. And yeah, essentially really battle tested for all sorts of visualizations at all sorts of scales. So Seabourn is a Python library which adds some improvements to Matplotlib. So there are added visualizations which Matplotlib doesn't support out of the box. There are improvements to the visualization objects. So instead of, like, we're going to calculate hex bin at the same time we're visualizing it, Seabourn separates those out very distinctly. Create a data object, visualize it. They have special support for categorized data. So if you're trying, like, yeah, if you have categories and then variables for those categories, you can create some visualizations very quickly with that. The high-level abstractions are similar to the data objects, and then it also has some other useful tools like color palette tools, which I've started to use a whole bunch. All right, I got a live demo. Who likes live demos? All right, so who would say that they are very familiar with Matplotlib? Who are somewhat familiar with Matplotlib? Okay, who has never used this library before in their life? Okay, cool. This particular presentation I went through for the people who are particularly never have seen it, so we're going to talk about some of the basic plotting functions. I have been working with Matplotlib for 10 years, and if you have a question, I probably have an answer for you, so we can go as deep as Jacob wants into this. So let's get started. So this is a Jupyter notebook. Most of you said that you've seen something like it before. I typically structure my notebooks where I have my imports, then I have my data, and then I have my analysis. So my imports here, I'm importing Pandas, which is a table structure for Python. Matplotlib, I pretty much always import Pylab as PLT, and importing Seabourn. So in Jupyter Notebooks, this little handy function executed within a cell, so I'm going to just execute that. This handy function is what allows the notebook to visualize it. There are style sheets. So in particular, here's a style sheet. SNS, which is what I imported Seabourn as, also has its own set of style sheets. And then you can customize all of these different things. So I'm making my plots, in this case, a little bigger and changing the font size. All right, so I have a CSV of, huh?
What's the difference between like Pylab and Pyplot?
Hmm?
So like I usually import matplotlib.pyplot, so you're importing
Yeah,
Pylab.
What I do.
is PyPlot.
Yeah.
I don't.
At this point, they're very similar.
Yeah, I think they're very similar. This is again goes back to that, like, Matplotlib is just contributed, or yeah, is contributed by a billion people, and they're like at one point we're gonna make this thing better, and so they started transitioning those pieces over. It behaves exactly the same.
In 2010, Pylab pulled in a bunch of extra crap that Pyplot didn't, and so if you had other things, it would cause problems.
Yeah,
But that's the one that basically.
yeah. I'm pretty sure
There's
it's
some
just-
history there, but at this point, they're identical.
Yeah. And then, yeah, so sheets. I'm importing star spectra, which is also tells you how old this is. It was shortly after I was doing Python, or doing astronomy research. And so you have wavelengths of light and normalized flux for these 5 different stars. And we're going to do some visualizations on that. So in this case, I'm going to pull out specifically the suns. And Seabourn actually has some useful data sets just loaded. The iris data set is a standard data set of irises. And these particular parameters for that. All right, so basic visualization. One of my most used go-to tools for data visualization is to go to the Matplotlib gallery. So Matplotlib has a plot gallery of just like everything, tons of things people have done with Matplotlib. It just keeps going. And they have...
This was like an eighth of what it used to be. Or sorry, it's 8 times more what it used to be.
Yeah.
Mm-hmm.
Last time I looked at it, it was like a third of the size.
Yeah.
Well, it fit in one page last time.
Yeah.
This is awesome.
Yeah.
A lot of them are like really, really small.
Yeah. So what I'll do in this case too is look through for something that is similar to what I want to see. So if I want like, okay, I need this scatter plot. Somebody has written out, here's how we create a scatter plot. We get some data. We call plt.scatter with x and y. The color is based on, or the size is based on this area variable, and the color is based on the color, right? Colors that they decided. And this is the visualization you get out of it. The gallery is really useful for finding those sorts of things. So our example here, I have my data frame, which is the sun, consists of wavelength and the flux. I am setting them as variables and then passing them into this function called plt.plot. And this function creates a line plot. And then calling plt.show actually displays it in the notebook. You don't necessarily have to write plt.show. Let's shrink it a little bit. There's the sun. Cool, huh? This is essentially this is the spectrum of the sun. For each of those wavelengths, this is the visible light spectrum, and this is around green. So if you didn't know, our sun is actually green. And then this is ultraviolet out here, and this goes into the infrared. And then this is the amount of light being emitted. Each of these little dips represents elements within the star's surface absorbing light.
Where's calcium?
There, and there. Jacob, why does it form this shape?
It's a black body.
What is a black body?
A opaque heat-emitting object.
Yep. So underlying everything, the star is a black body. It behaves exactly like any opaque shape that you would heat up. Emits light the same way. And then on top of that, you have the elements being absorbed. All right, so we're actually talking about visualizations. Whew, stars. So here's that same getting x and y. Matplotlib, what I'm doing here is I'm setting the title, then I'm setting x, and then I'm setting y, and then showing it. In this case, what I'm doing is I'm actually modifying the state of the plot. So Matplotlib in the background has some state of a plot that it's currently using. If I want to get the current figure it's using, I can go plt.getCurrentFigure. And then within a figure, you have axes, and I could do plt.getCurrentAxis. And so here's the visualization where I've added a title, added x and y. Again, Matplotlib has multiple ways to do things. So if I, instead of accessing it globally, I can use this access object where I'm getting, I could actually plt figure, create a new figure, add subplot, and the subplot position. Set type. And I'm creating the same plot, but this one was in an object-oriented sense, as opposed to editing some implicit global object. Who's used it this way before? Yeah. Okay. Anybody have an opinion on which one you should use? Yeah. Why?
Yeah. Get a little bit more control over bits and pieces.
It's more explicit for sure, right? Like instead of like something's happening in the background. When I first gave this talk, I recommended always doing this one. Since then, I always do this one in my day-to-day. And mostly, like, two things sort of drove that. In notebooks, your terminal is already containing a state, like your kernel has a state. So you're always executing cells that execute the state. So my visualization's pretty much always contained within a cell when it executes. It pretty much contains all of that.
Well, the thing with the notebook and doing that though is that you can end up with the wrong state, and
Yeah.
you can end up with you've got the block here and then it shows up down here, right? Because you have that global variables are bad, man.
I also, when I did this, I was creating. I actually was using Tinker to create like a desktop app. So Python's really powerful. You can create desktop applications using it. And I had Matplotlib visualizations going in, and at that point, like global variables just kill you. All right, so here I'm doing that same sort of same plotting the sun. I'm also, from my star spectrum, grabbing the stellar spectra for Arcturus and plotting that with different plot parameters, the color, the transparency, and adding a label. And the label, I add a legend. So this shows the stellar spectrum for the star and the stellar spectrum for Arcturus. And in Arcturus, you see that there is actually, it is emitting light at a different temperature, so its black body is shifted. It has different absorptions because it has different elements. It is a much bigger and much older star than the sun. No, younger star. I think Arcturus is younger. I don't know if we can say the age.
Ask for an ID.
Ask for an ID. Any questions on plot? Go for it.
Are there any advantages to global variables?
No, just don't. I have strong opinions about that.
They're global. Everything can, if you need something that everything can access, because the other option, the better practice is to pass that around to everything that's interacting with it. And that can be some overhead for you, but in general. Okay. Then so my pro tip on this is, so we had this function here where I plotted the sun, I plot Arcturus, and then I add some information to the plot itself. Often what I find myself doing is I need to create the same plot, but now I need to plot two different stars. And so what I'll do is I'll create a function that essentially wraps my plotting function, but is particular to the thing that I want to plot. I do this a lot where I set some defaults for that, so I want these particular lines to show up in a certain way, but then I create, I can pass in things that overwrite those variables. So the line width is always going to be a certain way, but I can always overwrite that. So this means that, and then my other tool that I use is writing a function for the plot attributes. So add a title, set the labels, set the legend. So then I can plot with just my own plot function, as well as plot attributes. And if I want to modify how thick the line is, it's fairly simple, and I can apply that to all of the visualizations that I've done for that. Line width 3, 4, or 1, and I can overwrite it if I need to. Pandas, which is that library that has a table, so this is a table structure, has a dot plot, which calls Matplotlib under Matplotlib. And so here I'm selecting one of the columns, I'm calling plot, and since the index is the wavelength, it uses the index, it uses that value, and then plots the spectrum. It plots that, and then I'm doing my plot attributes. So this is another way, instead of specifying X and Y, but I often find myself still specifying X and Y and using that because it gives you a lot more control. This is the Pandas way is very speedy, but doesn't always give you the same control over your variables and the data going into it.
The easy way around that is that you just create, subplots ahead of time, you defer your axis, pass those in to the Pandas plot argument, and then you have that full control on the backside.
I've had Pandas often it's had some problems with time sometimes. I have to explicitly specify X if I'm using time, as opposed to the way that Pandas does it. But there are multiple ways to do this, which is not very Pythonic. Here is a visualization. So I am now using the Pandas way to do it. I have the data frame, I call .plot. It's going to actually create one for each column. And then I passed in a set of colors. And here are your different spectrum for each of the stars. The stars that move this way are more red than the stars that are over here. And these bumps are related to the emission of helium, I believe. No? I can't remember what that is. This has been too long.
The red giants are older than our sun. As they are, our sun will become more big. So Arcturus, Betelgeuse, their spectra shifted over into the red.
That's true.
Vega is shifted towards the blue. It knows blue-white. Very hot, very young.
Yeah, but it's an overlay of 2 black bodies,
Correct.
which means that it's probably a binary star. No?
Betelgeuse is not a binary star.
Fair.
Yeah.
The hydrogen is consumed into helium. The helium goes to tritium, eventually to carbon and oxygen. And once it hits iron, well,
Yeah.
it either cools off or
Yep.
and it's over.
There's you didn't know you were getting star knowledge as part of this data visualization, but there you go.
It's impressive what you forgot over 4 years.
It's true. That is true. So there's other plotting functions. So I was showing the line plot. There's also histogramming functions. So here I'm specifying the bins. I'm histogramming the flux from the different stars and plotting that. I could do cumulative. Normed. Cool. So this shows you where the percentage of the light Oh. Matplotlib is
Huge density,
deprecated.
jeez.
Yeah, apparently.
You know, Matplotlib deprecated.
I know. And then there's a scatter plot as well. The scatter plot gives you lots of control over your sizes of points. So if you wanted to color or see based on the wavelength, cool. This. And you can add color bars to actually show the value. Again, the way that I learned all of that, right here. And when I needed a color bar, I'm like, okay, where do I see, this guy's got a color bar. Bam. This one's using the figure and axis instead of the global, instead of using it globally. All right, Seabourn. Seabourn adds some extra functions. Seabourn, I also go to their gallery examples whenever I want to do something.
It's a little smaller.
Yep, and they're like super fancy and modern. And so if I want to create a violin plot, which is a fancy histogram and visualization, or a box plot, it's a fancy box plot, they have a way to show the violin plots. They have other visualizations as well if you want to do some plots that will... They have some fancier box plot options. They also have categorizations. One of the plots that I really like is these joint plots, where you are plotting 2 dimensions, and then in the middle you're either doing a scatter plot, you're either doing some sort of density plot, which is this shown, and then you also have the density projected as a histogram. So if you just looked at the histogram for X, that's this. Just look at the histogram for Y, that's this. And then you have this density plot that shows you whether you might have some sort of bimodal shape or whatever the structure is in there as well. So in my particular use case, was specifying X and Y, the sun's flux versus Arcturus's flux. And so that's this scatter plot. But Seabourn is doing a lot for me. It's showing me the correlations between them, as well as the 2 histograms and the density for each. Here it is, doing it with a scatter version as opposed to a hex plot. You can also use the data frames that you create specifically to and specify the columns that you grab from it. Another plots that I use, that I've used quite a bit, these pair plots show you one variable versus another. So this is that same one, the sun versus Arcturus, but this shows you every single one. So if you have something that's higher dimensional, you can see the relationships in multiple dimensions in a single plot. And then they provide some other options, and so in this case, it's a scatter plot. Instead of doing these bars, it's making it look all nice and wavy. And the code is fairly straightforward for both of those. So it's providing these higher level abilities to create visualizations within your code. Questions? Matplotlib, data visualizations. Go for it.
Can you please briefly describe subplots? And earlier, I think you used an ND array 111 for one subplot. So we have 9 subplots, and how do we target and position each one of those within that ND array?
So the Matplotlib figure axes. I think if there's a good Essentially what so if you wanted a figure, the axis, this figure to add subplot, the 1, 1, so this represents your rows, your columns, and then if you laid them flat, that represents which one it is. So that's what this little encoding means. And so then, what did I want to do? Let's do this guy here. And we'll pass in that as a variable. So that is just showing. See, this is where I still have X and Y around, right? So it's the way that you'd make a grid. So if I wanted another subplot on here, you can actually create 2 subplots like that. So this shows you your positioning on some sort of grid. So if you have your figure, which provides you the structure for that, then this splits that up into an even grid, and it says which one of the values, which one of those squares do I want my plot to be in. That makes sense? And I will say that I've started using this, subplots. And then you specify width and height. Yep. And so this is showing me each of them. And then axes is a NumPy array of each of the axes that I care about. So instead of this like this, I would say your best practice would be doing this. And then if I want like a particular axis, so let's say I want 1, 1. It's actually a grid now. And so that is an easy way to access those. Yep. Cool. Other questions? Things you struggled with Matplotlib?
Here's more of like a, not necessarily technical question, but I kind of think of like basically the plots you were showing at the beginning is different from the plots you were showing at the end. The plots you're showing at the beginning, I think, is like, this is what you're presenting to somebody.
Yeah.
And to plot those, you actually kind of need to know the story you're telling, essentially, right? Like, you're not going to be able to just like randomly make the Napoleon plot,
Yeah.
right? And then there's like basically like EDA plots, which are like, I'm looking for information in this data. I was wondering if you have any thoughts at all on like that kind of thought, because yeah, I mean basically pair plots are great, but that's not necessarily usually where you're like handed to someone else to look at.
So what I would say is the same fundamental principle is happening. You are creating a plot. Your brain is processing it to try to learn something about it. There are essentially going to the gallery here to try to figure out, maybe you're making lots of different plots and you're not necessarily thinking about some other audience. The audience is you.
Right.
But I will choose plots from here where I'm like, okay, this is going to represent the data in a way that my brain can understand in a short amount of time. And so those concepts are still there. And as you explore and start to refine and find the thing that you care about, that's where you're like, okay, these visualizations actually do tell the story. Because ultimately you are trying to know something, and that particular piece of knowledge fits into a story. So when you think of pure like academic research, they're doing a lot of these plots. The end result is a graph that they put in a paper so that they're informing that story.
The final piece is the distillation of those intermediate steps, right?
Yeah.
And same with like the March plot, right? Like sometimes you'll go through and yeah, you're looking at lots of different plots and stuff like that. And maybe those aren't the ones that you show, like, aha, this is the end result. But each of those plots is asking a question. And every time you ask a question, you come up with a better question to ask, right? Next time, for the next go around, right? As you iterate through it. And sometimes that's a very smooth, gradual process to get you moving. Other times, like, you finally ask the right question with your data, and something will reach out and stop you with it, right? Something you didn't know was there. You'll have this eureka moment. And
oh, it's bimodal. There's two.
exactly.
Yeah.
I had a couple of those several years ago. I've been staring at this data set for 6 months, and I just asked the right question, and now I finally get it. And that sort of thing.
Was that a-
in business though too?
Yeah.
It was interesting. Like I remember I worked with one guy who actually, strangely enough, didn't let you use charts, and he was an executive. And the reason is because he had people. It was easy to hide behind charts. You can lie with charts pretty easy, and he had people giving very deceptive charts throughout his career. So he just like, show me the underlying data. You can show me a chart after I've seen the data, but if you need to be able to explain to me why this chart is something I should care about, right? So, because it's a really good book you should read is How to Lie with Statistics. It was written back in the 50s or something, but it's probably still one of the best books on data ever written. So, and it goes through techniques like chart jump and stuff, where it's like super easy to like hide behind charts and make them look great, and it actually doesn't tell you anything at all. It's just, it looks cool. It look good in a T-shirt, but it's not like something that's gonna drive business value.
It's a great book if you want to get into politics.
Yeah, sure.
Was that a compelling argument for you?
Yeah, no, I was just curious what your thoughts. One thing that kind of sounded like was that you're almost using like your Matplotlib as like a buffet, like a menu of a buffet. Is that like you're just looking like, oh, this might be an interesting way of looking at that? Is that the right interpretation of what you're saying, or no?
Yeah, I would say, I mean, I thought about like mathematics when you're trying to solve a math problem, or data science when you're trying to solve a data problem. You have a set of tools. You have like, oh, I can take the mean of the data. I can visualize this variable versus that variable. And so you're taking each of those tools and applying it to see if it helps you get to the problem you're trying to solve. And so like in here, like I actually think of each particular like Matplotlib is not necessarily a tool in of itself. It's each of the visualizations is a tool to understand the data. And so when I'm looking through here, I'm actually looking through my toolbox of like you don't have standard shaped like things. I'm like, oh, maybe this hex wrench will work on this like.
Right. And the other way that, in addition to that, the other way that I use it a lot is to say like, like I was saying earlier, like you're asking questions with your data, right? And you have a question that you want to ask, but you don't know how. And so you go to the gallery and you look at, you kind of have in mind what it is that you're wanting to visualize, and go through until you get find something that's close, and then iterate from there.
An effective technique I've also found over the years is actually to write out what you're trying to do. Sort of the equivalent of the Amazon 6-pager, where you actually have to literally write out. Like, so Amazon doesn't let you usually use PowerPoint. Like that. You have to write out your thesis and then distribute it to people. Because again, it's easy to hide behind PowerPoint too.
Yeah.
It's written for you and not for your audience, right? It's written for you to kind of escape and dodge around questions. You know,
Ooh, look at these icons. I have 3 icons.
But if you actually like write out like your business case, like word for word, like, and really understand the business case that you're trying to solve for, it's amazing what happens actually.
In Times New Roman,
In Times-
12.4
Sure,
fonts,
whatever you
right?
do,
Like,
Comic Sans, weird. But just writing things out, I think, is also like a really good thing. Because I tend to do that before I mean, Dylan knows. I'm probably like the least visual person in the universe. But yeah, you can get away with some pretty simple stuff once you really understand what you're doing. But yeah.
and you start to find the tools that work for you. So I don't reference this that much anymore, but early on, all the time.
The other, in addition to Matplotlib, Seabourn has a gallery.
Yeah.
That is also very.
That's what I
love Seabourn.
was showing here.
So
So,
actually,
and,
we used to see one a lot, and then now we switch to Plotly,
mm-hmm.
Alter and Locate, because it gives zoom in and zoom out, so you can visualize your
Mhm.
data. in a very
More
quick way.
interactive.
Mm-hmm.
So, yeah, for data analytics, it's great, but when you want to make a figure with goes to manuscript and papers, that's where you do Plotly, Locate, because it gives you really good colors. Yeah, it makes videos really happy.
Yeah. Both of these provide essentially a JavaScript layer for visualizing your data, and which is useful if you really want to interact with it, or if you want to then translate it to an external party. One of the problems with it is it puts it into a JavaScript layer.
Which doesn't go into an academic paper well.
Right. Or if you're trying to visualize 1,000,000 points, you
Yeah, so-
all of a sudden have to translate it into.
Yeah, so basically, for an example, even if you have genome chromosomes, right? So your data is like all chromosomes, all 22. But you don't want to show all 22, you just want to show like number 5. So you just focus on that and make it figure.
Yeah.
So
And
something like that.
yeah,
So
there's
so you don't have to write. Yeah, I mean, you got to.
yeah, you don't. The counter to that is that you don't ever visualize all 1,000,000 points because
Except-
there's no point to that. You do a density plot, like, or you visualize a part of it, or you bin it in such a way so that you can understand your information.
The other thing with like Altair and Plotly and things like that is that they take a fundamentally different approach to visualization than Matplotlib does. Where Matplotlib is imperative, right? And Altair and ggplot and these things are more like SQL in the sense that SQL, instead of being imperative, it is descriptive, or what's the right? Declarative. There we go. It's declarative, right? And you let the system figure out how to do everything else. It's more focused on the data and less on the axes and chart and all the chart lines.
That we want to see not all
Exactly.
Yeah, Matplotlib does all the steps you want to get there. These other tools are like, here's what I want as the result. Create that result.
Which has its trade-offs, right? A lot of the time, it's especially when you do exploration, that's what you want. But it doesn't give you this kind of great control necessarily. And also, those things have all come about since the last time you gave this talk. So.
Actually, no, but they were brand new. Yeah, they were brand new.
Like 2015, yeah.
Yeah.
Altair didn't exist.
Yeah, Altair's not on that list. And there's actually like some of these too for doing, like if you want to do, like use your graphics card for doing visualizations, there's actually a couple of libraries for doing that.
There's another one in that, a Polo views.
Oh yeah.
That's pretty cool.
Have you used it all?
I haven't, but
Yeah.
it looks really cool.
All right, we're over 9 o'clock. Let's call it.
But you didn't talk
We
about
get
the
there.
Riddis color map.
I know. You saw a secret slide. If you wanted to dive deeper into color maps, this is a really cool. Like, write it down before I leave this page. Great talk. This is how people understand color, and why this is the best color map ever, and why Jet sucks. This is the presentation to see. I'll just leave that up. All right.
Thank you.
Thank you.